Well, hi, and thanks for joining me here in my shop this morning on a rainy day. That means I might be in here a little more than on a nice sunny day. So now what I'm going to do with these two identical radios, I think I'm going to focus on the output tubes and the circuitry around them, and we're going to do some comparative testing back and forth and just see if we can find some differences. The first difference to note about these two radios is they don't have the same output tube. One has a 6F6, that's this guy, 6F6 output tube, which is the tube that's listed on the schematic here, 6F6. This radio has a 6K6, which is a slightly different version of that output tube. There's a whole bunch of 6 something 6 tubes that are output tubes that are somewhat swappable. So to get my head around this a little better, I've made a diagram. These are the two output tubes in the pin arrangement, cathode, grid 2, grid 1 plate. And they're both in the same arrangement here, the same angle, so it should be pretty easy to move the voltmeter probe or whatever back and forth. And I've written a little chart here, just shows some of the typical values that can be expected for these two tubes, and I've got that out of my tube manual, and the difference is actually significant in terms of, like, for instance, plate current. In the 6F6 tube, the plate current is 34 milliamps. In the 6K6, the plate current should be 25 milliamps. That's quite a difference, and an important difference too. Both these tubes are biased using a cathode resistor. Well, they're both done the same way, of course. So there's a cathode resistor. It's this one right here, kind of behind the big capacitor. Now you can see this radio has a paper capacitor here. This one has a molded capacitor. Really good chance this is a replacement. Almost certainly this is the original. You can also see this capacitor. This is a different tube, but well, actually it does connect into the tube that we're talking about. It does connect right here. So you see this big one in this radio and a smaller white one over here. This is a replacement. So I think it's quite clear that replacements have been made here that have not been made here, but at the same time I see these two capacitors which appear to have been replaced on this radio but not on this one. So it's kind of a mixed bag here between the two of them. It's not like one has been restored and the other one has not been touched. It's just not like that. There's a little of this and that. So I think the first thing, the easiest thing to do is just grab an ohm meter and go around the pins and compare the pin resistances. It's a bit of a crude test, but nevertheless, we're just, because I have two radios, I'm able to look for differences between them. So let's just check a couple things here. First of all, do I get a 0? And do I get a 0? Good. Okay. So we're just going to go pin 1, 2, 3, and around like that. So pin 1 is not connected, or at least there's no element in the tube. So this is pin 1. That means that the radio designers can do different things. So that pin 1 is grounded. This pin 1, I can practically see the grounding over here. Okay, pin 1, pin 2 should be the same. Pin 2, because I can see the wire coming over to pin 2. Okay, off of pin 2 is a little resistor. I think that's the plate resistor going to ground. Pin 3 has these capacitors on it. Pin 3 here. Okay, so I'm on the 28 megohm scale there, and we're getting about 3 megohms. Okay, and on this one, what do we get? We get an open circuit here. So we're dealing with the output tube, so it's important that the speakers be the same, and the speaker's plugged in on this radio and it's wired in on this one. So why the difference here? This is quite a shocker. Let's try that again. Oh. Break time for the meter. Here we go. So it is around 3 on this radio here, and on this one it's definitely just showing more than 3, more than 20 rather. Put it on that. Okay, so it's kind of a weird thing going on here. 200 megohm scale, we get 1.4. 20 megohm scale, we should see 1.4. We should see it here also. Okay, so there's definitely something kind of weird going on here. These very high resistance readings are difficult to make with consistency. So that shows 1 megohm on the 200. 10 megohms on the 20, and this will just be over, I'm sure. Yeah. Oh, I'll take that back. 1 megohm here. What exactly is causing this thing to read differently? It usually indicates that the impedance of the circuit you're measuring is very, very high, and the meter's acting a little bit weird. Not, you know, nothing weird goes on with electricity, by the way. It always does what it's supposed to do. Electricity never behaves weirdly. Well, hey, what am I stopping for? Let's keep going. So we found one pin. Let's keep going here. Found one pin wildly different. Okay, so we'll leave it on the 2 megohm scale. That was pin number 3. Pin number 3 is the grid number 2, the screen grid. Oh, wait a minute. 1, 2. No, it's the plate. Oh my. Weird things happening on the plate. Okay, the next one is G2. Okay. G2. Check. Yep. Greater than 2, greater than 20 on that one. Eight megohms on here. .4. Look at that. 900. So on my 200 megohm scale, short to the chassis reads 900K, almost a megohm. That's a little more like it. Okay, so on the 2 megohm scale, it's open there, but not here. That's 2 now that are different. Okay, let's keep going. So this will be the next pin. This is grid 1. So this is the signal grid. Doing the funny hop around thing that I see. The voltage is actually going like this, up and down, according to what the meter says. Okay, so 0.6, so 600K, and what do we get on the other one? Well, finally, something similar. Well, okay, so 500K and 600K, so those are pretty similar. Next pin is open. It's unhooked, unconnected, and open. I'm on to the pin number 7, short to ground. Pin number 7, short to ground. Pin number 8, grounded. Pin number 8 shows a ground. Shows what looks like a ground. Yeah, that should be grounded there. Oh, take that back. No, pin number 8 is a cathode, and the cathode is grounded through the cathode resistor. So I think we're reading the cathode resistor here. 608 424. And on this one, 460. And they look to be exactly the same resistor, original resistor. Let's check this again. 460, that's close to what it's supposed to be. 680 is quite a ways away. So the recommended cathode resistor for the 6K6 is 400 ohms, and for this one it's 430, 440. Depends on it always depends upon the plate voltage. Higher the plate voltage, the bigger the resistor you want. So this one seems high. Now, what am I doing here? Am I going to try to restore this to a 6F6 circuit, or am I going to make this work best with a 6K6? The answer might lie in, do I have another 6F6 tube? And you know what? I have these guys, 6F6 here. Actually, that's a good looking tube. This one's a little more beat up, rusty wise, but so let's think about this. Probably the 6K6 is in here because somebody had a 6K6 and didn't have a 6F6. And they decided to put in a 6K, what they had. Now on the other hand, maybe a 6K6 is the replacement for the 6F6. Let's see what it says here. 6K6. Glass octal type used in output stage. Glass? Octal type? Oh, that's right, 6K, not 6F. 6K. Output stage of radio receivers and triode connected as a vertical deflection amplifier in television receivers, capable of delivering moderate power output, relatively small input voltage. So that's the key. Small signal coming in, you get a pretty good signal coming out. Tube may be used singularly push-pull. Tube may be supplied with pin 1 omitted. Tube requires socket in position. Outline section especially important that this tube, like other power handling tubes, be adequately ventilated. Yeah. Okay, now sometimes it says this tube is primarily used for the replacement of something else. But it doesn't say that here. It doesn't say that anywhere. So I think my original story is true. The 6K6 got in there because somebody had one, stuck it in there, crossed their fingers, and it worked good enough. So I think the best thing to do is restore it back to 6F6, which isn't really doing anything because it's not like this has been rewired to handle the 6F6, 6K6. You know what I mean. Do I know what I mean? So I think what we're going to do is we're going to change the two cathode resistors here to the same thing. And what does it actually call for on the schematic? What does the schematic have to say about this? So we look through here. Okay, 400 is written there quite clearly. 400. We could go just a little higher. If we wanted to, higher would be a little better than lower. Okay, two resistors. Well, and that'll fix. Well, that'll fix things. I'll do that now. Okay, so I've changed the two resistors. This is the cathode resistor from this radio. Let's see if it's once it's out of the radio, it might test a little bit different. Let's just see what we get. Doesn't look like it, does it? So almost 700 when it should be 400. .460, so exactly the same readings, or really close to the same readings. I put in, you can see these, can you see these in the camera? Really hard to see, but I put in this type. This is a high wattage 5 watt resistor. It's a little bit overkill. in terms of wattage, but it's exactly the called for resistance of 400 ohms. Okay, now I think I mumbled something about bypass capacitors. These two here, but they're not. They're not actually bypass capacitors. The cathode resistor is not bypassed in this radio. Wait a sec. Yes, it is. Yes, it is down here. So the bypass is coming from the big metal from this, and on the other radio it's up on top. So we'll assume that's okay, because there's a good chance this capacitor is actually good enough. These kind, I found my own experience, when they're in these metal cans here, they're actually pretty good. And if the radio involves a field coil, often it seems as if the capacitance here isn't as critical in eliminating power supply hum and stuff like that. So I don't jump right in, and when I see one of these, I don't jump right in and change it, especially if the radio exhibits no hum. You know, what are you doing? So what are these two capacitors, which I thought were bypass capacitors? So this is a small, it's supposed to be 0.004, but this is definitely 0.005 here, and it just runs between the cathode and the plate, probably suppressing some kind of oscillation, high frequency oscillation, or some RF or anything that might be there. So I don't think that's terribly critical to the radio's operation. Let's get the ohm meter going here again. Hello. We're going to go around those two pins. There was another strong variation, and I don't think changing the cathode resistor has changed much of anything in terms of doing this comparative test. But let's go around again, because okay, check, good. So we just did this is pin number 8 here, so we see it to ground now. I don't know why we got two readings there. Just under 400, and the other one just under 400. Perfect. Okay, so let's go 1, 2. We were on pin 3. We were seeing some huge difference, weren't we? Megohms. Maybe not. Okay, 1.2 on the 200 megohm scale there, and over here, exactly the same, 1.2. Okay, next guy. He just coincidentally read 1.2 also. Hey, come on. 1.3. See, when you get on the high scales here, it's tricky to take these readings. 0.9 is the same, and 1.3 is the same. Okay, let's keep going. .6 on the 20 scale. Roughly the same. I thought there was another pin that was wildly different. Grounded there. Grounded there. And we're back around to pin 8. I thought there was some more funny business in here. Well, what we'll do is, because we're not getting anywhere here, they almost all read the same thing. There's a small resistor there, 8. Is that supposed to be? $800K or 300? Which one is it? Like it's going to ground here. So if we read here, we're going to get the resistance or something less. 1.5. I checked these before and got the same reading. So that's coming out at 600K. And over here, oh, I can see the colors on this resistor. Green, probably black, and yellow is what I'm going to guess that is. Now, how come we're getting... about the same. There's the 0.04. This one would be a 0.04 if it matches. Not good to rotate these on their leads. Don't you know it? It's hidden in behind here. I can't see the value of this. Well, that's a 0.04. That's a 0.05. This one down here is a pretty big looking resistor, capacitor. 0.0047, 0.05. So 0.05 doesn't appear on the schematic unless I simply missed it. 0.02, 0.004. I don't see it. So I think it's this one. It has to be this one, because it's connected to the it's got 25 written there. I wonder what that little 25 is. 39. That must be a part number. It's have part numbers listed sometimes and not other times. I don't get it. 0.04. So how did 0.05 get in there? What do I do? Put a 0.05 in there? 0.005, 0.004. It is, looks like it's the kind of thing that would be stopping oscillations, or it's right between the plate and the cathode. Calls for a 0.004, so I'd be more inclined to do that. But for now, I think we want to start these guys up and measure the voltages on these pins. I think that's the next rational step. Plus, it gives us a chance to hear what these things sound like. It's been a while since I've operated them. Okay, and we're going to be doing this basically with the loop antenna on the back. Switch is the same. Volume's right down. The radios are set to the AM band. Okay, we'll start them up. See what happens. Okay, on the dim lights. Looks like we're getting good operation there. Leave it on the dim lights for now. We'll go looking for some voltages. So first we'll check the plate voltage on the output tube. plate voltage on the output tube. The plate is 1, 2, 3, wasn't it? Double check. 1, 2, 3 on the plate. Let's go see. What is the plate voltage? Plate voltage would be right here. Well, that can't be it. Well, it could be. I'm on restricted power, and one radio doesn't develop much B plus on restricted power. So that's what that one shows, and this other one shows more. Let's put on full power. Turn them up. Turn them up. Okay, both working. Now, looking for full B plus. Full B plus on pin number 1, 2, 3. 1, 2, 3. Just want to make a mistake. 260. And over here, 250. It's really, really close. It's lower than I thought, though. I thought it was up around 300. Wait a minute, what am I testing here? So wasn't there a little resistor off the plate connection? Plate, grid 2, grid 1. Plate, grid 2. 270. So I don't think this is too good here. We got 250 on the plate, 270 on the screen. I don't think that's how these are supposed to be. Wrong spot. 260 on the plate. 280 on the screen. My understanding is you don't normally run the screen at a higher voltage than the plate. This isn't going to say anything here. Let's take a look at the tube manual. What does it tell us? Take a 6 F6. 6 F6. Okay, so typical operation plate. Hey, plate supply voltage, plate. Kind of lost track of what I was doing here. Too many things going through my head at once. Cathode bias 250. This is where we are. Bias resistor 400. So we 410. We put a 400 in there. Totally forgot what I was going to do. Oh, that's right, screen voltage. Okay, grid number 2, supply voltage. Well, you know what? It shows it exactly the same. It shows it the same as the plate. The plate and screen should be the same. Plate and screen should be the same, but they're not on this radio. The plate is getting its supply. Yeah. Well, that's interesting. Okay, so the supply line is here. Kind of see this on the. So this is the B plus supply line. The B plus reaches the screen grid directly and reaches the plate through this with 800 ohms of resistance in it. So the plate is going to be lower than the screen. I thought there was some rule against that. Apparently not. Okay, so that's fine. So let's look at the cathode voltage now, and we'll see. This will give us a hint on plate current going through the radio. So this will be a pretty low low voltage. 16, that's just about dead on what we want. Just about 16. 16. So again, I look at a 6F6. I gotta close my book all the time. 6EFG. So 6F6 under cathode bias of 250, you expect a, well, they're not going to list it here, you little tricksters. They won't list it here, grid voltage, because, well, maybe they list it as 16. You know what, 16 is going to be right around the money here, for sure. So if you get 16 volts of bias on a 400 ohm resistor, you can almost bank the right current is going through there. Well, we don't have to bank it, we can calculate it. Oh no. Another calculation. I gotta get a calculator in here. So if we're looking at 400 ohms, 16 volts over 400 ohms. Oh my gosh, I think I can divide this out. So it's a 0.016 divided by 0.4016 will become roughly double plus a little bit. So 16, 32, say 40. So 0.04 or 40 milliamps. I get 40 milliamps, 400 ohms. Oh, wait a minute here. That would mean 10. I don't think I did that right. Okay, so I just double checked with the calculator. Yeah, I got it right. 40 milliamps. So turns out with the no signal current flow through these tubes, the 6F6 should be about 50 milliamps, and the 6K6 should be about 60 milliamps, if I remember right. The 60 milliamps is coming from a much higher plate voltage. Plate voltage is a lot lower. So what that all adds up to is 40 milliamps is a pretty darn good reading to get for either of these tubes, really. You really want the plate current to be just low, a little low, if anything, not a little high. So that's perfect. I think we've done a good job here at dealing with what did we deal with? Well, we still have capacitors to change all around that output tube. So I'm going to go ahead and do that. It's 1, 2, and that's it. Just 2 capacitors to change. 1, 2. There's a 0.02 protecting the grid. Wow, where's that one? We need to make sure we do that one. So the grid is pin number 1, 2, 3, 4, 5. Grid is pin number 5. Let me turn the power off here before I get myself into trouble. Silent radios, silent killers. So we come around to 5. 1, 2, 3, 4. Well, 5 has this great big honker on it. .02. This must be a .02 capacitor. Now this looks more like the right size for .02. This looks crazy. I'm going to replace it anyway, so let's monkey around with it here. DC working volts, 1,000. I think that's the reason this is a big capacitor. It's 1,000 working volts. There it is there. 0.01. This is, well, it could say 0.02. Hard to see. So that's what's happening there. And this one, it's also kind of, see, it's a good thing I turned these radios off. Stick my fingers right in there. And if you rotate these, you ruin them. So I'm rotating it. .02. A nice looking capacitor. So we'll do a couple .02s in there. That'll be these two here. Away we go. Okay, so I've changed out 2 capacitors in each of these radios. So I got 4 capacitors, 2 here, ready to be tested. Let's see what happened here. Did we do the right thing or not? I'm sure it's the right thing. So we'll start with the 2 capacitors that came from my radio. That's these 2 here. First one is just checking the voltage rating, 600 volts. There's no concern here. No concern in putting too much voltage onto the capacitor. Let's just get a little closer here. So it's very hard, as I've said before, to get this stuff on video camera, but you want to watch the gap in this eye here. Okay. Get it on 25 volts. I'm going to apply 25 volts DC across the capacitor. That'll cause the eye to close and hopefully, well, not hopefully, we'll see if it opens again. So that went really fast. Okay, 250. So this capacitor is in pretty good shape. That's 250 volts on it. If I can affect the camera here. 250 volts on it. That's a little better. And the eye still opens, doesn't open all the way. So not as bad as many capacitors I've taken out of radios. Let's try this guy now. He's good for 1,000 volts. Right. You're starting again, 25 volts. You'd think if it was built for 1,000, it would have lasted pretty good. Here we go. So that popped right open. Popped right open, 250. Popped right open. So, in fact, now just to be sure, I'll disconnect one lead. What happens if the capacitor is completely open? How does it test? Watch how fast this eye goes. So you don't even see it close, really. So this capacitor is good. It's good, but it's going in the garbage. Now, how about the other radio? This is not my radio. You gotta kind of bet this capacitor is going to test good. It looks really rugged. Made in Japan by Cherry. Never heard of them. Cherry. Okay, 25 volts. That was a little slow. Let's try that again. A little slow. Bet you it doesn't open on 150. Opens partially. So, not terrible. Not terrible. Oh, this one. I didn't do this one. This is the last one. 0.004. I mean, that looks to be in great shape. The seal looks beautiful on this. I'll bet you this tests just like new. I'll put 10 cents down on it. 10 Canadian cents are riding on this. Is she good? No. Huh. How do you like that? Not so good. Not terrible though. I've certainly tested capacitors that are way leakier than these guys. So I don't think this would cause the radio to not operate. There's absolutely no sign of any kind of failure in this capacitor. So even without moisture getting in, assuming no moisture has gotten into this, which that's an assumption for sure, something else must be going on inside it to make it deteriorate. I'm sure when they're brand new, you do that test and that magic eye will pop open almost instantly, even at say 400 volts on the capacitor. So okay, so we can't expect much change from changing out those capacitors in the radio's operation. So shall we just play them one more time? See if we can actually listen to something this time. So think we're good to go. Good to test it after making changes in it anyway. Okay, full voltage. First this radio. And what can we get? We expect a station right in this area. Scratchy up here. Doesn't seem to want to pick anything up. Okay, there we are with that one. Let's try this radio now. Any one station would be good. Crickets, crickets. Nope. So neither radio is tuning in to anything. What, have I got this done wrong? I don't think so. I think I'm on the short wave band now. Short wave over here. Wow, isn't that similar, right? Holy smokes. Have to deal with the scratchiness. I think that'll be our next. So quiet down the tuning. This might be the local oscillator from this radio. Listening to this one. Yeah. So you can tell from the scratchiness, as I tune this radio, can be heard in this radio. That tells me that the scratchiness is probably from the local oscillator jumping around. And I'm sure it's from the same, all from the same thing. Probably a dirty shaft here. Easy to fix when the time comes. Okay. Well, they sure seem similar. And I guess they should. What do we got left now? So we've got the output tubes under control. We still got a 6F6 in here and a different tube over here. I'm going to leave it that way for now. Next stage back, we're not hearing anything out of these radios. So maybe the next wise thing is just keep working our way back in the radio. And the next thing will be the detector tube. We'll snoop all around the two detector tubes and ultimately change some of the components, the capacitors and that, and see where that gets us. Great, thanks so much for watching, and see you on the next video.